All right, page 2. Number 6, this starts in slope-intercept form, so I don't need to change it. I like this form because it's easy to graph. So I zoom in on this graph. I'm going to start with the y-intercept. The y-intercept is at -5, so I'm going to plot the point here down at -5. And then I use the slope to find one other point to determine my line. Well, the slope is what's right in front of x, and that's a 1 right in front of x, even though it's not written there. And slope is usually written as a fraction, so I'm going to write 1 and put it over a number. Well, I can always put a whole number over 1. So now I have this fraction 1 over 1. It tells me that for every 1 that I rise, I have to run 1. And both of those numbers are positive. So for instance, if I start at this point, that red point that I've already put on the graph, I would have to go up 1, and then I'd have to go to the right 1. So I went up 1 and right 1. And I'm going to put a point right there where I landed. I'm going to keep going in that direction and get all of these points. Okay? And then I will draw a line through all of those points. And there's my line. Now I'm done. Notice this one's not an inequality, so I don't need to shade anywhere. I don't need to make it dashed or solid. It's already solid because it's an equal sign. Okay, it's an equation. Alright, number 7. This one's very similar. I just have a different slope and a different y-intercept. So I'm going to put a point at the y-intercept, which is at +3. So I'm going to put a point right here. Okay. Then I'm going to use the slope, which is -7 over 2. Since it's negative, I can do one of two things. If it's -7 over 2, I can write that two different ways. And I'm going to use both ways just to show you what happens. So one possible way is to read it as -7 over +2. And that would be graphed like this. I would start at this point. Oh, let me get you. There we go. So -7 over 2. I would start at the 3 and go down 7 to begin with. So I go down 1, 2, 3, 4, 5, 6, 7. That was down 7 because it was -7. And then it's a +2 in the bottom of that fraction. So I'm going to go to the right, 1, 2. I'm going to end right there. So there's my point. So now I've got the point at +3 and the point down there at 2, -4. The other way to think about this slope right here is I could think of it as +7 over -2. Now, if I use this, this will go off the graph, but I can guess where it would be. So if I go up 1, 2, 3, 4, 5, 6, 7, I would have to go to the left 2, 1, 2. So it's probably going to be about there, but again, my graph doesn't go up that high. So I'm going to have to guess where this line would be. And it's going to be in between those points that I've made, so it's going to look something like this. There's my line. Okay, that's number 7. Number 8, this one's different because this one's in standard form. So this one will be different than 6 and 7. I need to change this into slope-intercept form, the form that 6 and 7 were in. It'd be way easier to graph. So in order to change it into slope-intercept form, I want to solve that equation for the variable y. So I want to get this variable y all by itself. So in order to do that, I need to first subtract x. And in fact, I'm actually going to rewrite this equation over here. So I have x minus 3y is equal to -6. I'm going to subtract x from both sides of this equation. When I do that, these two terms go away, and I have -3y left over on that side. And then x, I can't take away an x from 6. So I'm going to write this as -x minus 6. And then all I have left to do is divide by -3. but I need to divide both these terms by negative 3. So now I have y is equal to a positive 1/3 x plus 2. And now I can graph this. So I have the y-intercept at positive 2. So I'm going to put a point here, positive 2, and then go up 1, and then over 3, 1, 2, 3, and put a point right there. And then I could copy that over here, over there. I can even put 1 point right there. And that's where my line's going to be through all those points. All right, so there's number 8. And then number 9, this one says y equals 2. So this is one of those weird lines, either going to be straight up and down or left and right. So I'm going to first start with where is y equal to 2? Well, I know y is equal to 2 right there. And y is also equal to 2, for instance, way out here, or out here. As soon as I start to plot some of these points, I can realize, hey, this is going to be a left and right line, a horizontal line. Y equals 2. Okay, that one's nice and short. And then the last one on this page is write the standard form of the equation of the line given the slope and the y-intercept. So the slope's 1, the y-intercept is 2. Now it says write it in standard form, but I'm going to start by writing it in slope-intercept form and then change it to standard form later. So what I'm going to do is write slope-intercept form, which is y equals mx plus b. And then they give me the slope is 1, that's my m value, and my y-intercept is 2, which is my b value. So I'll write y equals 1x plus 2. So there's slope-intercept form. So if it had asked for slope-intercept form and not standard form, I'd be done. But they ask for standard form, and I'm only one step away from getting my answer. All I need to do is take 1x and move it to the same side that y is on. In order to do that, I need to undo positive 1x to move it to the other side of the equation. So I'm going to subtract 1x from both sides of this equation. Okay, so I will have negative 1x plus y is equal to positive 2 because these go away. And there's my standard form equation. Negative 1x plus y is equal to 2.